Good afternoon. I think I'll speak mostly to this board here. It just seems a bit hard for me to go both ways. So let's see. Okay. This talk's mostly going to be a very brief description on what is a porphyry copper deposit and how basic geology is what you need to find this. That's one of the world's largest porphyry copper gold deposits, Grasberg in Indonesia. For many years, it was the world's largest operating gold mine as a byproduct to the copper. So, very quickly, these are big, powerful systems. They affect cubic kilometers of rock. However, what causes them are fairly small intrusions that can be 1/2 kilometer to 2 kilometers wide. The intrusion is like a finger connecting to a batholith at depth. They often occur within 1 to 4 kilometers of the Earth's surface. They occur in clusters, just like the fingers on my hand. And, well, porphyritic texture, that's why they call them porphyries. And I won't go into the physics of why that is, but the rocks have a porphyritic texture, and that means they have little crystals that are larger than the surrounding fine-grained ground mass. Multiple phases of intrusion. Lightning doesn't strike once or twice. You often get 5 to 6 to 7 phases of intrusion that have all come in during the lifespan of the deposit, which can be less than 100,000 years. So there's several stages. Each intrusion brings a pulse of magmatic and hydrothermal fluids and metals. And this is all about fracture permeability. How do you get water through rocks that really aren't porous and permeable? This is not the oil game. You fracture them. And this makes the permeable pathway for the fluids and the metals. And of course, we get a wonderful characteristic metal zoning. And this metal zoning is very useful for finding more. The cores of these systems are often iron, copper, sulfur, gold systems, going out through molybdenum into distal gold, silver, lead, and zinc, and even further out into manganese over the course of maybe 5 to 10 kilometers away from the center of the system. That's Batu Hijau in Indonesia. All right, well, where do they occur? Well, they occur in what we call oceanic island arcs and continental margin arcs. We have large porphyry copper moly systems. They tend to like the continental arcs, whereas the copper gold systems are not only in the continental arcs, but in the oceanic island arcs. Now, just in case you wondered about, are these things worth finding? Yes, they produce over 70% of the global copper, nearly all of the molybdenum, 20% of the gold, lots of rhenium, tellurium, lead and zinc, silver. These are magnificent deposits. If you put that into dollar values, if you look at using $3.50 and 1,700, so I've been conservative there. The largest 20 deposits in my little registry contain more than $100 billion in copper and more than $20 billion in gold. That gold is a byproduct. That's per deposit, all right? That's not a total lot. That each deposit's got more than $100 billion of gold, of copper, and $20 billion of gold in it. And if you take the giant ones, more than $500 billion in copper and $100 billion in gold as a byproduct. That's a complex slide. These slides will be made available to you. You can go and look at these references. The main point here is that that's the surface of the Earth when this this porphyry formed. We go down 5 kilometers, and these metals with the porphyry core sitting here, with high copper metals going out into basically sulfur-rich pyrite, lead, and zinc. And there's all sorts of metals that allow you to work on the zoning. And you can use various ratios of metals that form close, such as copper and molybdenum, divided by metals that form far away, such as zinc and manganese, as proximity indicators in your soil and rock and drill hole database. So the key is, how do we find these things? And I will argue that in many places, as long as the rock is sticking up out of the ground, it is not covered by sand, okay, or overburden, you just have to use basic geology. And it works. And it works again and again and again. And not just years ago. It's still working today. And Apala is a good example of that. So that's the discovery outcrop at Apala in Ecuador. And so how do you take that outcrop from basically mapping? So here they mapped out the abundance of those little white quartz veins. We went ahead and made some drill holes. We did level plans by hand. We did cross sections by hand. put it into a three-dimensional model, and then we've related a direct correlation between the abundance of those quartz veins that you saw in outcrop to the amount of copper and gold. It's very predictive. You're drilling and you have a 0.5% veins, you say, hey, let's keep going, because when we get to 5% veins, we're into the 0.9% copper core. All right, so Batu Hijau is where I first learned this method in 1996. Batu Hijau has got over 15 billion pounds of copper and 15 million ounces of gold as a byproduct. This is one of the drill pads there with about 10% quartz veins. If you map out the abundance of veins from outcrops and drill pads and trenches, you get 5% veins in orange. And that happens to directly overlie the deposit using a 0.5% copper cutoff that even goes down to more than 1 kilometer beneath the surface. All right? So very effective, just mapping those veins, and there's the first 3 drill holes. All of them hit ore at Batu Hijau. So just mapping the veins here is useful. There's other things we can map too, the abundance of copper-bearing minerals, the style of alteration. So there we are with the 80-meter wide zone of 2% sheeted veins in the Apollo Creek, all right, found in May 2012. Drill hole 5 went down deep, not only tested the finger, 80-meter wide finger at surface, and drilled down 700 some odd meters, and then got the kilometer-tall porphyry body with the sort of 0.7% copper equivalent intercepts over 1,000 meters, all right? So Apollo was giving us the finger, right? And we had to recognize that finger, that it might be connected to the hand. Fortunately, SolGold did. Another example of some of the channel samples in the creek of the discovery outcrop in percent copper and grams per ton gold. So what the guys did very quickly, basically on the discovery was drill hole 5. By drill hole 9, I taught them a mapping method, the Anaconda mapping method, which I learned in 1996 at Batu Hijau, and it's been applied since the 60s by Anaconda Copper Company geologists throughout the world. And they made a map, and they basically mapped out intrusions. Pardon me. There we go. Yeah. And so they mapped out the abundance of these quartz veins. And what they realized is that there's the first 9 holes, if you will, or actually 8 holes, and that's projected from drill hole 9. This is into the hill. There were no outcrops here. The streams, we saw this pattern of veins. And they said, well, what happens? It looks like it's open. It's going into the hill with no outcrop to the southeast. So they planned a hole, and it took a little while to actually drill that hole. That was drill hole 12. Which is still the best drill hole on the project to date, at 1.6 kilometers at 0.6% copper and 0.5 grams per ton gold, including 600 meters of 1% copper and 1.2 grams per ton gold. Not bad for mapping veins in the creek. Well, we go ahead and make our cross sections and level plans. All the colors there are just the abundance of these B-type quartz veins. And you can see we've broken out different rock units from left to right, being the oldest rocks to the youngest rocks. And this is the abundance of veins. And you see this magenta, that has the most amount of veins, and that is the early intrusion that brought the metal to the porphyry party. All right? And each subsequent intrusion brought a bit less, quite a bit less. So we've used that to then work out geometry of the deposit, and here we're mapping copper and gold by intrusive type. So again, there's the wall rocks. You get that magic mineralizing early intrusion, and then subsequent intrusions bring less metal to the party. All right, lovely. And then you can see there's a good relationship of the magenta and the yellow, the early intrusions, to the high-grade copper core, which, that drill section there is about 2 kilometers, 1.7, 1.8 kilometers tall. Quite an ore column. All right, so Liam went through this quickly. There we have, using a 0.2% copper equivalent cutoff, it's about a 2 kilometer long by up to 1 kilometer wide by 2 kilometer deep ore body. At a 0.45% copper equivalent, you can see it's a very large footprint. Look at the 500 meters for scale. And at 0.9% copper equivalent, which, that's a cutoff of 0.9% copper equivalent, which give you in the average at 1.4% copper equivalent that Liam cited at 420 million tons. What a nice way to start out your block cave. So there's a cross section through there, and mainly it's a bit, the pattern's better on this side. This is a bit washed out. But what we have here is those are the good intrusions, the pink and yellow. All right, these are all the quartz veins, correlating very well with the 0.9% copper equivalent high-grade zone cutoff. But this is interesting. This is molybdenum. And it's not a lot of molybdenum. It's 10 to 40 ppm molybdenum. It's not economic, but you can see molybdenite on fractures if it's better than 10 ppm molybdenum for the geologist in Sol gold. So it gives you a halo. So when you get molybdenite on fractures, you keep going. And it's like a jelly donut. If you're drilling through here, all that molybdenum on fractures, you keep going. There's the high-grade core. You don't stop until you're outside the molybdenum halo on the other side. So I've just showed you molybdenum, and which you can see visually on fractures. Quartz vein abundance, which you can measure, are great ways to drill your deposit. And when you've got 14 drill rigs turning at one time, you do not have the luxury of waiting, if you're lucky, 3 weeks, sometimes 7 weeks, for assays to come back. Okay? So we use these geological proxies. And with copper deposits, you can see the copper. Isn't that lovely? Chalcopyrite. So that's to say, yes, this method does work. Okay, this method of the Anaconda method of recording, mapping data is what's driven this discovery. And adding all that, so those great grades and amount of metals, 21 million ounces of gold, 23 billion pounds of copper, and 92 million ounces of gold is from basic geology. Okay, well, where else has this been applied recently? Hot Chili. You're going to have a talk by Christian just after me. The Cordillera deposit. When you sum it up with the nearby Productora deposit in coastal Chile, near a highway and all these great things, you get a fair amount of metal. There it is. So we get about 3/4 billion ton for about of rock for about 3 million metric tons of copper. So it's almost 7 billion pounds of copper and less than 3 million ounces of gold. Now at Cordillera is where we've applied this method fairly recently. We have about a 2.3 kilometer zone strike length. And you're looking down, and we have these basically 3 little fingers. And imagine this is like a 3-humped camel, okay? You have this big structural zone that's northwest, and the handle's got not 1, not 2, 3 humps, okay? And each hump has got copper and gold in it. And the biggest hump is Cuerpo 3. And these colors are just showing you different phases of intrusion, determined much the same way. We've done this at Apollo. Much the same way people have been doing this for 50 years looking at porphyry coppers, early, late, etc., and wall rock. All right, so again, here, the Hot Chili team has made a graph showing copper, gold, silver, and molybdenum by rock type. And again, you're seeing you want to be involved with the magenta and red early to intermineral intrusions. They're the ones that brought the metals to the party. Okay? Now we'll do a cross-section through Cuerpo 3, the largest deposit in the Cordillera chain. And you see, again, those intrusions. You've got a gently southerly dipping stratigraphy of volcanic clastics and sedimentary rocks. And then you've got these pink and red intrusions coming up with late yellow intrusions. And you'll see that most of the good stuff, greater than 0.3% copper, not copper equivalent, is centered on the magenta and red intrusions, but also in their fractured wall rock. Okay, and there's quartz veins involved here as well. So if we look again, there's the abundance of quartz veins, up to 10%, and you can compare it to the 0.4% copper and the 0.1% copper shells. A pretty good correlation of elevated quartz veins towards higher grade ore. All right, and again, talking about molybdenum, we have a molybdenum halo here as well at greater than 50 ppm. Here, some of the actual high-grade ore has molybdenum, but you get a little bit more around the outside. So these are the lungs of the system that tell you where the heart and spine are. Okay, quartz veins, interesting as well. You can measure quartz veins at surface. You can measure them in drill holes, as shown here. And there's clearly a northwesterly trend following that major northwesterly belt of the 3 Cuerpos. But also what's interesting, and we'll kind of summarize this and make this simpler, is the quartz veins become kind of flat at a certain RL, below about 500 meters. I'll have to walk closer to see that. At 500 meters RL is where you start getting a lot of flat veins. And this happens to be where there's a lovely high-grade zone, and subsequent work shows a little bit of a blowout here. So again, the understanding of not just the abundance of veins, but the orientation of the veins and multiple vein sets might help predict where you are in the system. So to close off, that's a whirlwind deal. Hopefully I got it within roughly 15 minutes. But Porphyry deposits contain massive amount of metal. You just cannot get around that, okay? Whatever value you use, it's a lot of money. And yes, some of them take a lot to develop, okay? Absolutely. And field-based methods and the integration of the data you collect. It can be geophysical data, geochemical data, geological data in 3 dimensions. You don't need Leapfrog or Surpac or Micromine, although that's really helpful. But we've been doing this for decades with, you know, what do we call them? Light glass tables. Light tables. And, you know, what technology? And cross-sections and level plans. But of course, we do all that and bring it into the 3D environment. Okay, absolutely. We've got computers, so let's use them. But it's effective and it works. So 3 deposits where it's been useful: Batu Hijau, Alpala, and Cordillera, and many other. But those are just the 3 I've taught you today. Thank you for your patience.